we're gonna find the aluminum, right? The aluminum. So we're gonna be given the mass, right? And this is the volume. And so this is the mass of the aluminum rod, and then this is the volume of the water, right?
No, the volume of the rod.
The volume of the rod after it's been displaced in the water.
Yes.
Okay. So once we have that, we're gonna plug that information into this equation here to find the density. So it'd just be mass divided by volume. What is this here? Just so the volume is just length times width times height.
Yeah.
Of the aluminum rod. Okay. And then after that, we take that equation to find the thickness of the aluminum rod. So
Or it's
then,
like an aluminum, like they give you like a sheet of aluminum.
the sheet
So it's
of
just real
aluminum.
thin. Yeah.
Okay, yeah, the sheet. So then we take this number here, and then we would do the length and the width of the sheet of aluminum to find the thickness, because we don't have the height. The height is the thickness, right?
Yeah.
Okay. And then so we multiply length times width of what we measure of the aluminum, and we use that over here, density, what we calculate over here, divided by length times width equals thickness. What is this? I don't remember this.
Oh, well, so to find the density, it gives you like a whole, like it gives you like 5 sets of like mass and volume. So
Oh,
you
because
just
this
want to
is
do like
5, we're gonna do it like about 5 times, and then so we'll average
yeah.
that.
Well, I don't know if it's exactly 5, but I just do 3 of them. 3
Okay,
of them
whole
is like a
times.
good sample, yeah. So
Okay.
do 3, and then you average those, and then that's what you use for your density.
Okay, so we'd do this first, actually, we'd wanna average
Mhm.
before we do that, and then we would go into this. Question mark?
Yeah.
Yeah. And then the graph that we have to form is just mass on this side, volume. It's pretty much just rise over run, be in the middle. That's how we're gonna solve for, I guess, the aluminum portion of the lab.
Oh yeah, don't forget that because you're measuring your aluminum sheet, you're measuring it in centimeters, but your chart's probably gonna give you the volume in milliliters. So just remember that 1 cm3 is 1 milliliter. It's direct.
Right here.
Yeah. Because your chart, it'll probably give you the volume because cm3 is volume. So it'll probably give you your volume in milliliters, but you're gonna be measuring your aluminum piece with a ruler. So just remember that like they're direct because you're gonna have to find your density. Your density is gonna be grams over milliliters. So remember you can replace that grams over milliliters with grams over centimeters cubed, and it's like a direct equivalence. You know.
Okay, I got you.
Yeah. So like, okay, so you have they're gonna give you your mass of whatever the hell, whether it's Mg, NHO, whatever the blah blah blah, or it's diphosphorus pentaoxide, they'll give you the mass. So you take your mass of whatever the hell, and then you divide it by your molecular mass of that. So if you have 10 grams of diphosphorus pentaoxide, you divide it by the molecular weight of diphosphorus pentaoxide. That's what this fraction means. For every 1 mole, blah, blah, so you're just like dividing it by the molecular weight. So you divide it by the molecular weight, mole over G for whatever you have, and then you get the moles. Okay, so you went from your grams of diphosphorus pentaoxide divided by the molecular weight. Now you have your moles of diphosphorus pentaoxide in that sample. So then you have your moles of P2O5, and then you use your ratio. So remember, your ratio is always what you want on the top and then what you have on the bottom. So we have diphosphorus pentaoxide, and we want phosphorus. For every 1 mole of diphosphorus pentaoxide, there's 2
Moles of phosphorus?
Yeah, 2 moles of phosphorus. So 2 over 1, and you can swap that with whatever ratio you need. Like if you're doing this, it's a 1-to-1 ratio because there's 1 mole of phosphorus for every 1 mole of magnesium, blah 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 blah. And so and then you times your moles by that fraction you get, and then you have your moles of what you want. So what we want is phosphorus. That's what's on top. So now we have our moles of phosphorus, and then you want to find the grams of phosphorus in that sample. So now that you have your moles, you times it by the molecular weight of mole G. So you times it by that mole G, and now you have your grams. So you go from your grams of, okay, so say you have A and you're trying to find B, you go from your grams of A, divide it by the molecular weight of A, and then times it by the ratio of B over A. A is what you have, B is what you want. And then that gives you your moles of B. So now you have your moles of B, you want to find your grams of B, so you times it by the molecular weight to find your grams. Yeah. And then you just use that for blah blah. And to find is always going to be in there. So if you have a compound and you know how many of that compound you have, like you have,
I guess my question is, how do you know that's a 1-to-1 ratio and that's a 2-to-1?
well, because because on P2O5, for one of these, you have 2 phosphorus. Yeah. Yeah, that's what we were trying to explain.
Oh my gosh, bro. I'm like
That's
literally
not even-
like.
I think that's what you were confusing yourself about, is that you weren't seeing that, so you were like, this problem is not making sense to me.
Yeah.
Thank
You're
you.
welcome. And then in MgNH4PO.
Like I've literally been looking at it this whole time, but
Yeah.
like it did not click in my head that that's what that was. Okay.
Yeah. And then for this one, you literally have, for every one of these, you have 1 phosphorus.
Yeah.
Yeah, so that's how you know. But just remember, what you want is going to be on the top, and then what you have is going to be on the bottom, so you don't get them flipped out.
Okay.
Yeah.
So sorry. Thanks.
Well,
No, I'm glad that you knew this before you went into your
Because if you
practical.
didn't ask, then you would never like know.
For sure. Thank you. Oh my god.
First of all, I have no idea if this is how you actually do it. But I was just like, okay, let me use some simple ass numbers so I can figure it out.
Okay.
Okay, so this is like the data set that you have. You did 3 trials and you got these 3 numbers for whatever you're trying to measure. So this is the thing. The actual number is the average of these 3, which is 4. And then the estimated number is whichever one of these you're using for the equation at the time. So you do 3 separate equations. You do the first one, which is 2 minus 4, estimated number minus actual. And then that's 4. And then times 100 equals, or 0.5 times 100 equals like negative 50. So it's 50% error.
Okay.
And then this one is 4 minus 4, which is 0, so 0% error. Because 0% error, there's nothing error.
Okay, so you're just taking your trials, which is your estimated number,
Mhm.
minus actual number.
And then this
Yeah, fair enough.
third one is 6 minus 4, so 2 minus 4, 200% error. Which shouldn't also be 50% error because this is 50%, I don't know. And then you add up all 3 and then and then average it out, and then you get the average percent error. And so percent error is just like how far off it is from the actual what it should be, how far off your measurement was.
Solid.
But I think whenever, at least on this, because your phosphorus thing is what they ask you to do the percent error on. So what you do, I think it asks you the percent error of how much like diphosphorus pentoxide you have. So the number you use for your actual will be like the number on the label. So if you have like 10, 16, 8, your actual will be like the 8.
Dude, I'm gonna write that shit down.
Because you're not like running like a whole bunch of trials and getting an average. So I think that's, at least I think, I didn't really like do it because I
What?
forgot the formula for it. But I think that's supposed to be what your actual is.
I'm actually gonna write this on my arm.
Yes.
Like, there's
Because
nothing-
that is like, that's the
percent error.
NPK
Like from my
thing,
thing.
or like
Whenever I like
where it tells you like nitrogen,
Yeah, yeah,
phosphorus.
yeah,
and- Okay.
use it with
So make sure remember which order it is.
Like the placement, yeah.
Yeah, but it's always the last one. The last one is the phosphorus. So that's really all you need.
Yeah, that's all you need.
What did you just ask?
It's the,
I'm gonna write
is it
down
NKP?
probably the ratio
NPK?
and like what she did
NKP.
except
NKP, and that's like it'll tell you the ratio on the bottle,
and
and it'll tell you how many, is it grams or how many like,
It's percent. It's
per-
percent.
the percent of how much is in that bottle. So like N is like the percent of nitrogen, K is the percent of potassium, and P is the percent of phosphorus.
All you really need to know is that the last one is phosphorus. So like you get 10, 16, 8. That 8 is 8% of your thing.
Yeah. Okay.
Yeah,
So then you're
supposed
just
to be
kind
8%.
of finding the estimated number.
Yeah.
So what about the reactions part, guys?
That one's gonna just have to be a scramble for me. That's the only one I'm having so much. I think the only problem is remembering if I include, because you include charges in them. So there's what, the ionic equation and then the net ionic. You include them in the ionic equations, correct?
Yeah.
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 You don't put them in the molecular model.
Okay, and then you have to take away like your, not your leftover, but like
the spectators.
The
Yeah.
spectators and the end, and that's your.
And
Yeah, like I know the process of what it is. I just don't have the rules memorized
Yeah,
enough
I
to
don't
do
have
it.
that either. Like the whole like, if this
Wow.
oxidizes or.
Just if it's like
If a metal and if fizzes, it's oxidation.
Mm-hmm.
That's what I got.
ooh, I have this.
You
written-
know automatically if it fizzles, that it's an oxidation. That's all I know for a
yeah,
fact.
because you're getting a gas by it.
Yeah.
Yeah.
If it's
But,
a solid metal,
Unless it's an acid-base reaction. But
I've
if it's-
literally looked at oxidation to be honest.
Yeah, I don't know about redox.
For the most part, your ox redox, because it doesn't ask you to specify which one, it says ox redox. If you have a solid metal, like just pure metal, it is going to be an ox redox. Yeah, because because the thing is, like all of the other ones, like, okay, so like process of elimination for like an acid base reaction, you need an acid and you need a base, and each one, like an acid is at least 2 parts, a base is at least 2 parts. Boom, acid base reaction. And then for a precipitant, you need, like two liquids to form a precipitant. If you start off, so if you literally only have 1, 2, 3, if you have only 3 components, it's going to be an ox redox because it can't be either of these 2. Yeah. So if you have a solid metal, it's only one. It's not,
Wait, so the bottom one is ox redox, the middle one is participant.
well, these ones just kind of look the
Oh,
same.
yeah.
But ox redox, you can definitely tell because
Yeah.
it has one pure substance.
By itself, and then and then it ends up losing its own
Mhm.
because it ends up changing. Okay.
and we'll have like
It's like rusting.
Yeah.
we won't have to like guess the compound, like what the compound is.
No,
that
it'll
we
be
added,
written. Yeah,
and
it'll
then
be
we'll
it'll be
know.
written on the label.
Okay, but we have to like balance it first.
Yeah, you'll have to balance it when you write the equation.
Okay.
That's
And then-
that's not too bad.
Yeah.
If you kind of know like the charge of like your acid,
Uh-huh.
which I think I can sometimes remember like 8 equals, but it depends.
Well, for that, even if you don't remember your polyatomics, if you have like an acid or base, it's never gonna be like 2 polyatomics
Yeah.
smack next to each other. It's always gonna be like one, like say like chlorine and then like sulfate. Okay,
Right.
so if you know chlorine is plus, or is chlorine plus 1 or negative 1?
I think it's
it's plus 1.
Yeah.
Minus
Minus 1?
unless
I don't know, but that's what I'm saying. But if you know chlorine is negative 1 and you have like 2 chlorine, that's 2 negatives. So you know
So you automatically know you
Yeah.
have like
that this is going to be
2.
2 plus.
Yeah.
Yeah. So if you know the charge of one, you can figure out the charge of the other. Because at the end of the
Right.
day, it's got to balance out to 0.
Exactly.
so
Okay.
is it a spectator if the oxidation state changes,
If the oxidation state changes,
or does it not change?
well, in this, if it's giving you 2, in this, if it's giving you, so say you have like iron for your,
Okay, I remember this part.
Yeah,
This
so
is
you
whenever.
like-
Okay.
iron 3 for your thing, and then you have hydrochloric acid, H2O. So that turns into, this is going to be really bad and ugly to view, but that goes from, what's iron?
Well, I thought it was like -3.